Thank you so much. Hopefully Cisco Live has been treating you well so far. My name is Kyle Winters, and can you not hear me okay? Oh, you can hear me okay? Microphone, all right. Awesome. Well, good? Perfect. My name is Kyle Winters, and despite what you may think, I am not a professional bowler. I am a technical advocate here at Cisco with the Learn with Cisco team. I've been working with Cisco since 2016, on and off, doing different roles such as solutions architect, technical marketing, business development. I left for a couple years to go work at some application security startups and came back to Cisco about a year ago as a technical advocate with a focus on security. And today I want to talk to you all about eBPF. We'll go ahead and start with just a simple introduction. What is eBPF? From there, we will go into some different examples and we'll leverage some different tools that exist for eBPF. One of them is simple example of tracing system calls using eBPF. We'll then go into packet filtering, similar to host-based firewalls with eBPF, and then actually go into a different tool by Isovalent called Cilium and do some host-based firewalls there. We'll talk a little bit about eBPF and Cisco as a whole. Why is Cisco talking about eBPF? And give you some resources at the end to help you along your learning journey. We do have a WebEx room for this, so feel free to join. There's a link very small in the bottom here, but by joining this session, you can also access it in the mobile app for Cisco Live as well. So I'll be monitoring that for the rest of the week, so if you have any questions or follow-up that's needed, feel free to post them in there, and I'm happy to answer them. So what is eBPF? And to start, let's take a look and understand what the kernel space is. So we're very familiar with operating on the user space, and that can be the different types of applications that we're using, like web browsers. It could be all sorts of different stuff. The command line is part of that as well too. A lot of code that you're writing is typically operating inside of the user space. But then we also have the physical hardware here. And that includes different things like network cards, storage, compute resources, memory. There's a lot of different vendors that exist and a lot of different technologies that exist in this physical space here. And when you're writing and using programs inside of the user space, how does the user space know how to communicate with all the different vendors and technologies that exist inside of the physical space? Well, that's actually where the kernel comes in. The user space only needs to concern itself with communicating essentially with the kernel space, and the kernel space itself then handles the communications with the physical hardware. So consider that kernel space as sort of an intermediary, a middleman between the user space and that physical hardware. It's a very stable piece of software. It's very difficult to change, and that's just part of the nature of it. It wants to be very stable. But there comes times where it's necessary to extend the capabilities of that kernel space to do new and unique things, whatever your use case may be. And I'll talk about some of those use cases here shortly. But like I said, it's very difficult to modify that kernel space right now. That's where eBPF comes in. So originally, it came about from the Berkeley packet filter. For a while, it was called Extended Berkeley Packet Filter, but that acronym has largely been dropped, and it's now just referred to as ultimately eBPF. So what it is, it's essentially C code, a very restricted version of the C programming language, written to allow you to do kernel-level functions. It allows for dynamic changes, so you can essentially load and update eBPF programs without requiring system reboots. So you can essentially make all these kernel changes, have them essentially take place instantaneously without having to reboot all of your systems. There are some significant performance advantages with this as well too, because eBPF is running in the kernel. It's further left, you can argue, from the user space. So before things are interacting with whatever it may be in the user space, the kernel space can intercept that if there's some kind of security-related or network-related use case that you're applying to it. So it has this just-in-time compiler that really is also enhancing the performance of these eBPF programs. So ultimately, it's making these programs into machine code in a way that you can execute them before they run inside of the user space. I know a little complex, but I'll show you some good examples of this shortly. But just to kind of give you some other benefits of eBPF, it's got built-in security into it as well. There's a lot of great tooling, a great ecosystem for tooling, and I'll talk about some of those tools here. But there's a lot that you can do with eBPF, whether it's networking, observability, or security. I want to talk to you all a little bit about some of the security, with a little angle on the networking side of it as well too today. But let's kind of go a little bit further into some of the core concepts of eBPF before we go into a demo. So the first thing to consider are the eBPF hooks. And this is some kind of process that triggers a system call that will ultimately interact with the kernel space and initiate your eBPF function. So it's kind of like a webhook, but it's operating in the kernel space. So some kind of event happens on your system, a system call is made, and your eBPF program can trigger. Now, we have this concept of helper calls as well too, and this is where a lot of the useful functionality can occur with your eBPF programs. So that eBPF hook triggers it from that system call, and inside of here is where a lot of different functions can take place. You can do things like search, update, delete key value pairs in memory, generate different types of random numbers for whatever process you're doing. You can collect and flag metadata inside of here, perform tasks with sockets like binding, retrieving cookies, or interacting directly with packets as an example. And you can also chain eBPF programs together. So you can have one system call that creates that eBPF hook, triggers one helper function, and then that will then trigger some subsequent functions as well too. Now, I mentioned key value pairs, and we're going to show you some examples of that in our demos coming up here. But consider these to be like eBPF maps is what they're referred to as. And it's just that key value store. You can store data essentially in the kernel, but what makes it unique as well too is that you can access this data outside of the kernel in the user space as well too. So it becomes a very valuable way for you to store data, leverage data that you're driving from kernel interactions. So what can eBPF do when it comes to network security? I've got a few examples on the screen here for you, but for one, eBPF can expect, filter, and manipulate packets at various stages in their journey through the networking stack. So this is very valuable. It allows you to do things like packet filtering, host-based firewalls, and it's got a high performance factor to it because it is operating in the kernel space instead of the user space. You can do DDoS mitigation as well, though, with eBPF. So it ultimately enables dynamic and scalable mitigation strategies against DDoS attacks. So you can essentially quickly identify and drop malicious traffic patterns that are identified as distributed denial of service attacks. You can also do things like intrusion detection and prevention in there. So being able to detect suspicious activity as it's occurring, that's something that you can do, ultimately creating profiles of what could be considered malicious device or malicious traffic, and then blocking it on the kernel level. One of my most favorite use cases as well is runtime security enforcement. So you can have essentially information provided in the kernel space about different types of malicious third-party libraries, as an example. So maybe you have a malicious version of Log4j that's being compiled and ran at runtime in some piece of software that you're using. You can have eBPF detect that malicious version of it and block it at runtime, so that way that particular application with the vulnerable version of the third-party library doesn't even run. So a lot of valuable use cases that are related to eBPF. Hopefully some of those are resonating with you and are of interest to you. So I'm going to go ahead and start by jumping into some simple examples here of eBPF. And we're going to start with tracing system calls with eBPF. So for the first couple of demos, I'm going to use a tool called BPF, Compiler Collection, also known as BCC. It's a very easy to use toolkit that has a ton of eBPF-based features in it. A lot of things are built and ready to go. You can invoke these from the command line very easily, which I'll show you, or you can build them into Python scripts as well. So to give you an example, let's go ahead and show you some of the source code for how you would trace system calls leveraging eBPF. So for start, we're importing our BCC module here at the top. And then I mentioned at the beginning, eBPF programs are C code. This is the C code right here inside of this Python package. So you can see ultimately we're tracing the system calls that are coming in, and in this case we're looking to see when a new directory is created. Just a simple example. So when that new directory is created, it's going to print out something, a little message for you like, wow, new directory. This here is where the eBPF program is actually loaded. So we're reading in this string that is the C code, loading that into our BPF program here, and this while loop here is ultimately just running to print and process the events as they're coming in. So a very simple eBPF program here of only about 24 lines of code, but this is just to kind of give you a taste of where you can start. And I'll show you a working example of this here in a second. But before I do that, one other example I'm going to show you in this first demo session is packet filtering with eBPF. So in this case, I'm going to have two hosts here. Our source is on the left, that's 192.168.9.130, and our target on the right here, similar IP, but 131 at the end there. And we're going to start by doing SSH and ping over to this host, and you're going to see that it's going to work. But at a certain point, I'm going to load this eBPF program, and it is not going to allow that type of traffic from this host any longer, ultimately filtering it out and discarding those particular packets. So the way that this is going to work is we're going to take a look ultimately at the IP header and the TCP UDP header that's coming in, and we're going to extract some important information out of there. We're going to take the source IP, the destination IP, the ports, and the protocol that are used. And we're ultimately going to take that bit of data, which is essentially a dictionary, it's a map, and we're going to compare that into a list of ones that we have stored that we want to deny and discard. So if the packets coming in match what we have in our configuration for packets to discard, then it's going to discard it, as simple as that. Ultimately, this is kind of how it works. This is a look at the C code here. Just some key pieces of information to render out, because some of you might not be experts in C. We're importing our different libraries here to handle some of the functionality, not just BPF, but also IP, TCP, ICMP, because we want to filter out and identify those different types of traffic. Here's where we're creating that data structure. Like I showed you earlier, we're ultimately storing it as a dictionary inside of the C module here. Here is where that hash map actually gets created, and down here is where that filtering logic is going. So it's a lot longer. I'll show you another little snippet of it here in a second, but you can see kind of operates similarly to what you would expect from a Python program. You're importing things, you're creating a data structure, initiating objects, and then performing your filter functions there. But if we take a look now, here's actually where some of the configuration and filtering is occurring. And a couple of things to point out here. In this particular example that I'm going to show you, we specify specific interface, but also we're specifying here that essentially the IP address that we want to filter out traffic for. So we've got this all configured. Let's go ahead and jump in now, and I will show you what this all looks like. So let me share this here. All right. So everybody can see that okay? So I'm logged into this Ubuntu One host. I'm in it on both sides because I'm going to show you a little example here first. But just to kind of show you the IP address there, it's that first host, that 130 host that you can see right here. So let's go ahead and start by just validating first that we have eBPF available on this particular host. And you can do that with a simple command here, more/boot config, and you can give it that, just hit that tab button and get that information there. And we're going to grep for config_BPF. And if you see here, config BPF equals Y, that means we have eBPF enabled in this particular device. So we know that we have it available there. Let's go ahead and test a couple different things. So I mentioned to you that BCC is the technology that we're going to be using for this particular session of it, and there's a lot of BCC capabilities that are available when you install that package. So just to kind of show you one here, let's go ahead and run this command here, bash read line. .bpfcc. Let me put in my password there. All right, so and this one is just a simple example of just to show you guys what BPF can do already. If I do something like echo hello, let me try that again. You can see it's showing up there. So it's tracing essentially the calls that are happening there. If I run IPAdder, you'll see that that shows up on that list as well too. So let's go ahead and actually run that Python program that we wrote. And if we take a look, that is here, eBPF trace calls.py. And if we take a look at it, it's exactly what I showed you earlier. So very short, very simple program. It's going to be essentially looking for any time a new directory is created, and it's going to write that data out to us. So I'm going to go ahead and run this just by calling it like that. And on the right side here, let's just go ahead and make a new directory, call it test, and you can see it captured that there very quickly. So imagine you want to set up some kind of monitoring on a host, be able to know what people are doing, send this log data out to some other system to be able to track it better. This is something that you can do by tracing these system calls, essentially creating an audit trail of what is happening on a particular host and doing it on a kernel level. One other example I'm just going to show you really quick before I go into the next one is just some of the stuff you can do on a networking level. So I'm going to go ahead and run this program here. And this is going to ultimately track for any kind of TCP connection that is occurring using eBPF. So I'm going to go ahead and run this. It's just TCP connect -bpfcc. It's a little, let me see if I can make that a little easier to read there. You get the idea. But let's go ahead and just do like a wget to google.com. And you can see we're tracking that network connections there. So you can see those are going out. We're communicating. It's ultimately failing because I don't have a tight exposed network right now, but you can see it's trying to make those DNS calls and resolve that using TCP there. So you can see we're able to also track things like network connections using BPF here. So I'm gonna go ahead and show you guys the next example, and let me clear this up here. And just to remind you, this next example is going to be that packet filtering example. So I've got my two hosts here, and just to show you now that I am on two different hosts. On the left side, we've got that 130 host. On the right side, we got 131. And just to kind of show you, remember, we're gonna filter out traffic for SSH on port 22, as well as pings. So let's just make sure that those things are actually working first. Let's go ahead and try SSH, Kyle at 192.168.9.131. And you can see that works. I'm logging in. I was able to SSH over to that host, no problem. And if I want to ping it, 192.168.9.131, you can see those pings are working successfully. Now, I'm going to keep that running, and I'm going to go ahead and just show you this eBPF program here while that's running. Let's just take a look at it just to kind of show you again. We have, as you can see up here, the host that we want to block it on, and we're pretty much ready to go. We're recognizing that it's any kind of TCP connection or ICMP connection. We're going to block that particular traffic there. So let's go ahead and run it. So we'll do sudo Python 3, run that program, enter in my password. And you can see things have started to slow down on the left side. No more pings are coming in. And just to kind of show you again that that's going to time out, we'll just go ahead and run that. And you can see those pings that were coming in at a steady flow before, no longer coming in. This Python package that's running that eBPF code is recognizing that there's ICMP traffic coming from the host on the left. That we're supposed to filter it out, and we're essentially filtering it out. And we can just show you again how that's working on the TCP level. I'm going to go ahead and try to do that SSH one more time. As you can see, it's not connecting. So this is a great kind of example of some of the networking capabilities that you can do with eBPF, trying to ultimately filter out specific types of network traffic. So hopefully that was interesting. Let me go ahead and quit this, because once you quit it, you'll see everything will start working again. So that's what I want to show you today with BPF CC or BCC. Let's go ahead and take a look at some other stuff though, because there is a lot more for me to show you. Let me go ahead and go back to my slides here. And sorry if that beach scene is tantalizing. I don't mean to make you jealous there. But all right, let's talk a little bit about host-based firewalls with Cilium. Now, how many of you have heard of Cilium? How many of you have heard of Isovalent? Cisco acquisition recently. They're very highly responsible for eBPF as well as Cilium. So ultimately, Cilium, it takes a bit more of a different focus than traditional types of server technologies. It's looking at cloud native and Kubernetes environments and asking, how do you effectively enforce policies, troubleshoot the network, and stay secure with as little effort as possible? Really, everything is so dynamic and happening so fast. You got things that are scaling up. You've got things that are microservices. Things don't necessarily always care about IP addresses and ports, whatever it may be. So that's where Cilium comes in. So it's ultimately Cilium, a networking and security solution for containers and microservices that utilizes eBPF to provide high-performance networking, load balancing, and security features. So it's ultimately enabling dynamic enforcement of network policies and offers some deep visibility into network traffic. So it's a very cool, powerful tool developed by Isovalent, and you can do a lot of interesting things with it. So it natively understands container identities. It can parse API protocols very easily and effectively, and it provides visibility and security that is incredibly simple for an end user to follow. Some of these amazing use cases you can see in the top here, like I mentioned, network policy, servers, services load balancing, a lot of security stuff, as well as OPSEC metrics as well too. So it's a very powerful tool. It's fairly easy to deploy. And I'm going to show you an example here of just kind of a simple web store that we put together, and we're going to leverage Cilium to establish some host-based firewalls on it to have a better secure architecture. So we have a couple different hosts here. We have, and again, this is like an online store, some kind of e-store, and some of you might be working in a similar type of environment, but hopefully you've all leveraged something like Amazon as an example. You've got your front end where users are interacting with the UI. You've got a catalog that's storing all the different things that you have for sale. And when somebody's ready to make a sale, they place an order on this particular pod. So these are 3 different pods that are running inside of this e-commerce environment. And without any kind of firewalling, the client that comes in is able to communicate with all of these different things, and they're all able to communicate with each other. Ultimately though, the client only needs to be able to communicate with the front end. Why would the client need to be able to talk directly to the order server or to the catalog server? It doesn't make sense. That opens up risk. So what we're going to do is apply some policy here where the front end is able to communicate with the order piece and the catalog piece, but they can't communicate with each other. And the client that comes in can only communicate with the front end because the client doesn't need to be communicating with anything else other than the front end. So the way that we're going to do that is first, we're going to set up a policy that denies all ingress by default. So nobody can communicate with anything to begin. We're then going to open up what we need. So we're going to start by allowing the front end to communicate with the catalog service over port 5678. And we do that with this bit of YAML here on the right. And you can see, just to kind of take a step back, it's very simple. We're just essentially naming it deny all egress and putting an ingress that has nothing in there to deny it. And then when we come in and we allow that ingress, we're essentially saying allow these things to communicate with each other so that particular host can communicate from the front end to the catalog on that particular port. We're going to do the same thing with the order service as well. So allowing the front end to communicate with that order service. And then we're going to allow ingress traffic to the front end as well. So we're going to simulate essentially a client that's coming in, communicating on port 80, and communicating with the front end, and making sure that they can only communicate with that front end component. So let me grab a sip of water, and then let's jump right into this. So let me go ahead and share my screen here once again. And we are, oops, wrong button there. There we go. Let's just kill that. We don't need it anymore. This is the one we want right here. Everybody can see that okay? All right, so let's go ahead and just take a look at our pod here. We're gonna do kubectl get all -n e-commerce, if I can spell it right. Did I spell that right? Yep. So you can see we've got our catalog, our front end, and our order pods all right there, ready to go. And you can see the IP address associated with them. 10.43 is kind of the subnet there, and you got 3 different IPs there associated with those 3 different devices. So let's just go ahead and create a test connection, essentially a test client, and just validate that we can actually communicate as a client coming in with all of these different components. So we're going to do kubectl run test client rm-it image equals curl images dash curl, which is just going to essentially set up a quick image where I can do some curl commands. -n cube system, label it equals, oopsies, yeah. All right, almost there. Thank you for bearing with me. One of the longer commands I have for you today. All right, so now we have our little curl client here, and let's just go ahead and test some of this functionality out. We've got our IP addresses up at the top. Let's go ahead and make sure that we can communicate with the front end first, 10.43.177.61. And you can see we're just getting a simple response here. It's HTML code. We don't have much configured on here, but you can see it's just an Nginx front end that's running. So we're getting a response back, which is what we want. Now let's go ahead and try a different one. Let's try, which one is this? This one is the catalog service. So we'll curl to 10.43.210.22, and that's gonna be port 5678. And you can see we get some data back. At the bottom there, it says catalog API available products. So we're getting available products back, and just to kind of move that up the screen for you, you can see that there. So we are able, as the client, to communicate with the catalog service. And let's go ahead and now communicate and just validate the communication with the order service. So similar command, I'm just gonna shortcut it here a little bit. We're gonna do 10.43.124.102, and again, port 5678. And you can see the orders API is returning data. So we're successfully now, without any kind of policy in place, as the client, able to communicate directly with the catalog service, the order service, and the front end, which is fun for this demo, but not a good practice in real life, because you don't want somebody messing with the systems. You only want the front end to communicate with the catalog and the order service. So let's go ahead and exit out of here, and let's apply some policies. So inside of here, I have some different policies to run, and I know it's a little hard to see it at the bottom there. Let me just, is that better from the back? Cool. Let's go ahead and just take a look at the policy. So we have a few policies that you can see here. And if we just open up one of these, let's just take a look at e-commerce policies. You can see it's got all that stuff that we showed in there earlier, allowing front end to communicate with the order function, allowing it to communicate with the catalog, denying all the ingresses at the start of it as well too. So let's go ahead and apply this. We're gonna do that with kubectl apply -f e-commerce. Oh, and really quick, let me just show you, by the way, I forgot to do this. Let me just show you as well that Cilium is running on here, because that is something that I think is kind of cool to see. You can just run Cilium status after it's installed, and you can see that we do have it running on here. There's no errors or anything like that. So apologies for not showing you that earlier, but let's go ahead and apply the policies now that are related to Cilium. And we'll do that again with kubectl apply -f e-commerce policies.yaml. So those policies have been applied. I'm going to apply another one as well that allows the ingress to communicate with the front end. So that way you can still have essentially your client come in and communicate with the front end. It's going to be a little bit similar, a little bit different. It's just going to be this here, front end allow policy.yaml. So that is all running. Let's go ahead and test this out now. And we'll start by jumping into the front end service and making sure that that can still communicate with our order service and our catalog service. So let me just grab the info that I need from that really quick. Get pods-n e-commerce. Those are the names of our services that are running there. And let's just go ahead and jump into the front end one with kubectl exec-it, and I'm just going to copy this for convenience sake. Save us some time here. -n e-commerce. All right, so now we are on that front end pod, and let's go ahead and just test the connectivity to those other services there. 10.43.210.22 5678. That's still working. And let's do the other one for the order service. 124.102 5678. That's working. So we know that the front end is able to communicate successfully now with the order service and the catalog service, but let's take a look at what a client would be able to communicate with coming in. So we're gonna run that same command that we ran earlier, that one that took me 3 hours to type in, this one right here, and let's go ahead and launch our curl client. So let's start here by seeing if we can communicate with the catalog service. So moment of truth, 10.43.124. Oops, nope, I got the IP wrong. 210.22 5678, and just because I suspect this is not going to work in terms of how long it's going to take to run, let's just put a minimum number of retries on it here. So let's see if this works. Drum roll, please. It's quick before to return. Now it's timing out. So that client that was able to communicate previously with that order service and that catalog service is now no longer able to. And let's just try it again on the other host just so you can see. 124.102. Again, before, no problem communicating before we applied that policy. Now, unable to communicate. But we can still communicate with the front end because we allowed that ingress there. So if we do curl HTTP 10.43.177.61, we'll say port 80, we're still able to communicate there. So a great way to do essentially some host-based firewalls, lock down the different types of devices that are allowed to communicate and the ones that are not allowed to communicate. It's very valuable, very useful, a great example of what you can do with eBPF. So hopefully that was interesting and exciting. And I know I showed you a lot of different things here in the command line, some complicated C code. Why ultimately is Cisco talking to you about eBPF? You may be wondering that throughout the week here. I know there's several eBPF sessions going on at Cisco Live. Well, for starts, we acquired a company called Isovalent. They're responsible for things like Cilium, Hubble for network observability, Tetragon for security observability and runtime enforcement. There's a lot of things that you can do. I didn't get to touch on Tetragon a whole lot today, but also a very valuable, very powerful tool that can do things further like process execution events, being able to trace system calls more effectively, providing some additional runtime security capabilities. But there's another thing related to eBPF that Cisco is talking about a lot lately. You may have heard of Hypershield. Yeah, you're interested in Hypershield, I know you are. What is Hypershield? Well, it's ultimately a new approach to an AI-driven data center. It's going to be leveraging eBPF under the hood. And I'll show you a little screenshot of some of Hypershield's capabilities here in a second. But it's ultimately AI native. It's designed from the ground up with AI integrations. It's allowing you to do high delivery, high efficacy, rapid response, continuous protection. I'm going to throw a bunch of buzzwords at you here, but ultimately know that it's cloud native, highly distributed, and all of this is ultimately leveraging eBPF under the hood, which is a very cool application and use case of eBPF. So that example that I just showed you, leveraging Cilium to do the host-based firewalling, you can do that with Hypershield. So this is a screenshot into Cisco Security Cloud Control, and you can see there's a Hypershield tab there on the left. We're doing a very similar thing here using the UI. We're ultimately defining which types of hosts that we want to be allowing and blocking on, and what types of actions that we want to take. So what I just showed you in a more complex way, you now understand kind of the ins and outs, the inner workings of it. So when you get your hands on Hypershield, you'll know exactly what's happening under the hood. So this and much more are going to be available to you with Hypershield. So check that out here very, very soon. But that ultimately concludes what I have for you today, and I appreciate all of your time. Some next steps for you. eBPF.io, a great resource put together on all things eBPF. We have some tutorials available for you as well on Cisco U, labs available on ISOvalence websites, and much more reading content on there. And it wouldn't be my job if I didn't mention, because I'm from learning with Cisco. If you don't know what Cisco U is, it's our premier learning platform. We have a free tier with tons of tutorials on there. So I highly recommend that you check that out. And check out the Cisco Theater booth over there. Lots of Cisco U theater sessions going on. Take some interactive stuff here in the DevNet zone. A lot of cool stuff to do. So thank you all so much. I really appreciate it. I hope you found the session valuable. We do have session surveys, and if you complete a certain number of things, you get some kind of leaderboard and prize. 5s are always appreciated. Please don't rate your score based off of how comfortable the seats were or how much background noise there is, because that affects us. Hopefully you rate it based off of the session presentation and the content that was delivered, and hopefully it was a 5-star experience for you all today. So thank you all so much, and again, I'll be monitoring this WebEx room and look forward to seeing you around Cisco Live this year. Thank you all.